So we're starting by graphing a quadratic, because what we're going to be doing today is going to touch on a function that's very like quadratics in terms of the way that it actually looks. So we start by graphing this. Remember how we go about graphing it. The number that's added or subtracted inside with the x determines how far it's been moved over. So x minus 3 is going to go right 3. The minus 1 on the end moves it up or down. In this case, that's a minus 1, so it's going to go down 1. So we got our first point here at 3, negative 1. Then from there, it's a quadratic. So we're going to use all the same rules that we would normally do with a quadratic. So a quadratic, we go over 1, up 1 on both sides because 1 squared is 1. Then we go over 2 and up 4 on both sides because 2 squared is 4. And we go over 3 and up 9 on both sides because 3 squared is 9. And then draw the curve in. This is the graph you should have gotten for that first one. Now we're going to look at some details about it. So first up, what is the range? It's been a little while since we've talked about range, so it's a good time to bring that refresher. Range, remember, is a description of all the possible y values on the graph. So this graph doesn't include every single possible y value. What is the lowest y value we reach? Negative 1, absolutely. And because that's the lowest, you notice the graph starts at negative 1 and it's going up from there. Therefore, the range is all the y values that are greater than or equal to negative 1. Because it's just that description. It's saying this graph includes everything that's negative 1 and up. All right? So now that we know the range, is it a function?
Yeah.
Yes, it is. Now, if you don't remember how we know, remember the vertical line test. I can draw a vertical line on this graph, and no matter where I draw that vertical line, it is only going to cross the graph in one place. Now, if it ever crossed the graph in 2 places, then we would say that it is not a function. But as long as it never crosses more than once, yes, it is a function. But then the new piece. What is the domain of this function? Well, we haven't really talked about domain to this point. We've talked about range a lot, which is very closely related to domain, but we haven't talked about domain. So before we answer this question, this is where we're going to take our notes for the day. These are the only notes for today. Please add this into your notes. So what I hope that you notice as you take a look at these notes is that this is really close to our definition of range. Range was all of the possible outputs that corresponded to real inputs. So basically, domain is just the other side of range. It's doing the same thing. It's the same kind of idea. Basically, since we describe range as a description of y values, domain is a description of the x values. So, now let's go back to our graph here and talk about how would we get the domain. Now, this particular graph is the type that we've been doing for a long time. I haven't talked about domain because every single graph that we've done up to this point has had the same domain. Notice here, this graph, you might think of it starting here, but that's fine. But from there, as I go to the left, so remember I'm looking at x values, are there any x values where all of a sudden there's no graph above it? No. I mean, no matter how far over I go, like let's say I went over to negative 10. If I looked above negative 10, I would find graph there. Now, in this particular graph that we made, it happens to be off the grid, but that doesn't matter because the domain is talking about just what would the graph include, not what did the particular graph that we made include. So then, as we go to the left, it keeps going on and on forever to the left, and there's always a value. You can square any number over there. What about going to the right? Can we square every number over there? Yeah, I mean, you could go up to 1,000,000. You can still do 1,000,000 squared to figure out how high you should go. So the reason why we haven't talked about domain is because they're all the same. All of them up to this point have been all real numbers. And that's going to be true of every quadratic you see. Every quadratic is going to have a domain of all real numbers because it does go forever left and forever right. Today, though, we're going to be hitting a function for the first time that doesn't have a domain of all real numbers. And so that's why we bring it up here. We're going to start today by taking a look now at the graph of y equals the square root of x. So please start by writing that equation, y equals the square root of x, above your next graphing grid. And then we're going to make that graph point by point so we can see what it is and why it is what it is. All right. So first up, since this is a brand new graph, I'm going to start it by just making a table of values. And I always like to start with a nice simple point. I always like to start with x being 0. So if x is 0, what is y? In other words, what is the square root of 0? Square root of 0 is 0, yes. So that tells us that we have the point 0, 0. Go ahead and plot that on your graph, the point 0, 0. Then I go to x being 1. Okay, what's the square root of 1? 1, okay, great. So then if x is 1, y is 1. So I can go ahead and plot that point. So now we have those 2 points. Those are very familiar. Notice those 2 points have come up a lot with the various function types we've had. 0, 0, and 1, 1. But it's not going to be the same from here. What if x was 2? What would y be? Well, what is the square root of 2? It's actually not a nice, pretty number, is it? It's a decimal. It's actually like 1.414, and it goes on and on and on. I don't want to have to mess with those ugly decimals. So I'm not going to worry about that at the moment. You don't have to plot those decimal numbers. So what about 3? Can I take the square root of 3 then? Does that give us a nice, pretty number? No, that's also a decimal. Okay, so then what about 4? Can I take the square root of 4? Yeah. Okay, so then that's where we're going to go next. We're next going to go to a next value of 4. And what is the square root of 4? 2. So then we can plot the point 4, 2. One of the things that can sometimes be tough for people when first graphing this type of function is we're not graphing every x value like we normally would, because some of them give us ugly decimals. Now, it still gives us a value there. Just because they're decimals, I don't want to worry about plotting those. So if x is 4, because that's easy to take the square root of, what number should we go to next for our next value? Well, what's the next number you can take the square root of and get a nice and pretty number? 9, yeah. So my x value that I'm going to try next is 9, because the square root of 9 is 3. So I have the point 9, 3. I can go ahead and plot that one, 9, 3. Okay, what would be the next x value you would choose? 16. Okay, so if I did 16, the square root of 16 is 4. The point 16, 4, though, is off my graphing grid, so I'm not going to worry about plotting that. All right, so I've gone as far as I can to the right. What about to the left? What if x was negative 1? What's the square root of negative 1? Well, we talked earlier in the year about the square root of negative 1. It equaled I, because it's imaginary. The square root of a negative number doesn't work, or insofar as it does not give us a real number. It goes into imaginary numbers. We can't plot imaginary numbers on this grid. So, in this case then, since no negative numbers are going to work, I can go ahead and just draw the graph in from there. You'll notice that our graph starts at 0, 0. There's nothing to the left of it because we can't take the square root of a negative. And so that's our graph. Notice it's a little bit different, right? It's a little bit different insofar as it actually starts at 0 and there's nothing to the left of it. And notice there's nothing below it either, because when we take the square root of a number, it gives us a positive every single time. All right, now I did start you off with a quadratic today. I do want you to notice the similarity between this and our quadratics that we have. If I was graphing a quadratic, all these numbers would be the same, except our x's and y's would have been switched. So you notice it's the same pattern, it's just swapped for x and y because, well, square root and squaring, they undo each other. So it would kind of make sense that they'd be opposite there. Just a little bit of another way to remember. All right, so now that we know that, let's take a look through those same questions that we answered on our quadratic at the start. So first up, what is the range of this function? Now remember, of course, range deals with our y values. So in this case, it only goes down so far. What's the lowest y value it reaches? 0. Goes down to 0. And we're going up from there, so it's got to be y is greater than or equal to 0. All right, square root function. Is it a function? Is square root a function? Well, it passes that vertical line test, so yes. There's never a point here where if I draw a vertical line through, it's going to intersect in more than one point. So yes, it is a function. Now domain. The domain here is not all real numbers. So domain, remember, deals with our x values, so we start by writing down x. Now in this case, it only goes down so far. What's the smallest x value it reaches? 0. Okay? And notice we're going to the right from 0. That means the numbers are getting bigger. And it's going to be all of the x values that are greater than or equal to 0. Because the x's can be 0 or higher. So notice another way to think about domain here. Remember, it's everything that we can plug in and actually get a real output. Notice why it can't be -1. If I plugged in -1, it'd give me an imaginary number. That's why the x's can only be greater than or equal to 0. Now, if you know this graph, because this is our parent function, remember parent function just means kind of that starting graph, the most basic one that everything else builds on. If you can graph that, then you can graph this. So please take a moment, try graphing this on your own paper, and then we'll go through it together. And of course, write the equation above the graphing grid. So in making this graph, we're going to start it the same way we started that first problem we did. Notice this one, just like the first problem we graphed, has a shift right 3 and down 1. I know it's right 3 because the -3 is in with the x. And it's down 1 because the -1 is hanging on the end. It follows that same pattern as squaring it does. So first point is at 3, -1. From there, we're copying the same graph as our parent function. It's just our starting point is now here instead of at 0, 0. So from that point, remember our first point was at 1, 1. So I'm going to go over 1, up 1 to get to my first point after that. Now to get my next point. Remember my next point was at 4, 2. When I count over 4, 2, I'm doing it from that starting point. Because remember 4, 2 is relative to 0. So I'm doing it relative to this first point. So I'm going to go over 4 and up 2, which drops me off at the point 7, 1. And then from there, I would then go over 9 and up 3. But unfortunately, in this case, that takes me off the graphing grid. So I don't need to plot that point. I can go ahead and draw the curve in from there. All right, now we can start answering the questions down the side. What is the range here? First of all, for range, does it deal with x or y? It is the y. And so it's going to be y is what? Greater than or less than? Greater. Yep. And it's going to be greater than or equal to what number? -1, because that's as low as it goes. Because remember, range is dealing with y values, so I'm looking to see how low does it go there. All right, domain now. Is domain dealing with x or y? X. Yep. Are x values getting bigger or smaller from that starting point? They're getting bigger, therefore it's greater than or equal to. And then what are the x values greater than or equal to? 3. Yep. So they're greater than or equal to 3. So it starts at 3 and goes right from there. And then is this one a function? Yeah. It also passes the vertical line test, so yes, this one is a function. So next up, we're going to graph y equals 2 root x. So again, write the equation down above the next graphing grid and go ahead and make the graph of this. So in this case, that 2 that's out in front of the square root, you notice we're multiplying it by 2. Multiplying is not a shift, it's a stretch. So this one's not been shifted at all, meaning that you're still going to start at the point 0, 0. That's unchanged. What the 2 is going to do is it's going to be that vertical stretch. So instead of going over 1, up 1, you're going to go over 1 and up twice as far. So instead of over 1, up 1, you go over 1 and up 2. So then next up, we would normally put our next point at 4, 2. But again, I'm doubling how far up I'm going because of that vertical stretch. So instead of 4, 2, I'm going to go to 4, 4. Because I'm going up twice as far. The over doesn't change, only the up. Normally from here, I go to the point 9, 3. But instead of 9, 3, I'm going to go up twice as far. We're going to be up at 9, 6. And of course, after that, I'd have to go over 16. That won't fit on the graphing grid. So go ahead and draw your curve in from there. So we now have our graph. Whenever you're asked to find domain and range, starting by looking at the graph is a great way to start. It's a great way to just be able to look at it and see. So for our range, again, range, is that dealing with X or Y? It's dealing with Y. Yep. Is it going to be greater than or less than? Greater than, because they're getting bigger. And technically it's greater than or equal to because it actually hits that starting point. And what is that starting point? 0. So we got Y is greater than or equal to 0 for the range. What about domain? Is domain X or Y? Still with our X values, absolutely. Are X values getting bigger or smaller? Bigger, therefore greater than or equal to. And they're getting bigger than what number? 0. So our domain here is X is greater than or equal to 0. Notice our starting point was 0, 0. So our domain and range are exactly the same as they were in our parent function. All right, and is this one a function? Yes. And going forward, if the parent function is a function, all of them that are based on it are also a function. So you're going to find that every square root is a function. So we can just call that good from here. All right, next up we're going to be dealing with negative square root x. So next graphing grid, write that equation above it, and go ahead and make that graph, and then of course we'll go through it together here in a minute. All right, so when you have the negative out front, remember that that's going to be a reflection across the x-axis. Since it's a reflection across the x-axis, there's no shift. Therefore, your first point, it's unchanged. Your first point is still at 0, 0. The difference is that from there, we're not going to go over 1, up 1. A reflection across the x-axis means it's been flipped upside down. So instead of over 1, up 1, it's going to be over 1, down 1. Notice we're still going to the right, though. Since it's a reflection across the x-axis, flipping it upside down, it's not flipping it both directions. It's only flipping it upside down. So up becomes down. All right, so the rest of it then, hopefully straightforward. Instead of over 2, up 2, it's going to be over 2, down 2. And instead of over 9, up 3, it's going to be over 9, down 3. Go ahead and draw the curve in through those. All right, now those questions. First up, what is the domain? Is domain dealing with the x or the y? It is dealing with the x. Don't let yourself get tripped up there. All of a sudden I asked the domain first this time. So domain is dealing with x. So are x values getting bigger or smaller? They're starting here and going to the right, so our x values, they're still getting bigger. So it's still greater than or equal to. And our x's are greater than or equal to 0. Okay. But now the range is dealing with y. But are our y values from our starting point, are they getting bigger or smaller? Smaller. So then that's why y is less than or equal to here. And that starting point is 0, so our range is y is less than or equal to 0. All right. We're going to do one more graph, and then we're going to call this good. Y equals negative 3 root x. Please write this equation above your next graphing grid and graph it. All right, so to graph this one, we got two different transformations. We got a reflection and we got a stretch. Notice neither of those are shifts. So your first point is still going to be at 0, 0. From there, instead of going over 1, up 1, we're going to go over 1 still. But instead of going up 1, you're going to go down 3. So our first point's going to be over 1, down 3. Next up, normally we would go over 4, up 2. In this case, we're not going up, we're going down because of the negative out front there. And instead of going down 2, we're going to go down 6. So it's over 4, down 6. All right, next up, normally we go over 9, up 3. So instead of over 9, up 3, we are going to go down. And 3 times 3 is 9. So we're going to go over 9, down 9. And then go ahead and draw that curve in. Domain. Is domain x or y? It is x. And so our x values start at 0, and then they go to the right. So our domain is x is greater than or equal to 0. Range is y values. Our y values start at 0, and they go down from there. So our range is y is less than or equal to 0.